inverted cone is being emptied at the rate of 6 cubic meter per minute. The altitude of the cone is 24 meters, the radius is 12 meters. Find how fast the water level is lowering when the water is 10 meters deep. First, we draw the cone. Radius is 12 meters. Height is 24 meters. This problem talks about time rate, meaning the change in height over change in time. It also involves the volume. We multiply this by dV over dV just equal to 1. So through manipulation, we can get dx over dV equal to dx over dV by dV over dV. Okay, from the problem, we already have the 6 meters cubed per minute. That talks about the volume and time. We already have that in here. So what we need left to solve is the dx over dv. We can solve this from the problem here cone. The volume of a cone, which is 1/3 pi r squared h. Now, if we integrate this, there are 2r and h. We cannot integrate with 2 variables. So we replace r in terms of h using ratio from the this is a right triangle. This is 12 over 24. The ratio is to the new one, which is r over h, and we cross multiply with 24r plus h, and r is 1/2 h. We now have the r. We substitute it from here. So we can get 1/3 by 1/2 h squared h. We simplify, we can get 1 over 12 by h cubed. Now, this is the volume that we derived now. And we will now integrate this. So we will get this. So we first derive the volume in terms of h. We now then derive, we can get 1/4 by h squared. That is now the value of our dv over dh. Now as you can see, in here is dh over dv, and in here is dv over dh. So we will just simply find the reciprocal of this value. We can get dh over dv is equal to 4 over by h squared. Now, from the problem, we have given 10 meters deep for the height. So we substitute the h instead. We can now get 4 over 5 10 squared. 10 times 10 is just 100. So 4 over 105. In the problem, we talk about the discharge. So the answer will be negative. That is how we solve the discharge of the stove.
Problem 2. Water runs into a conical tank at the rate of 9 feet cubed per minute. The tank stands point down and has a height of 10 feet and a base radius of 5 feet. How fast is the water level rising when the water is 6 feet deep?
So first, we have the problem. If you're given a problem, first you need to write the event, which is dv over dt equals to 9. And after that, we try to find the volume of our solid. Volume of all V is equal to 1/3 by R squared 8. And before we try to solve the problem, notice that we have two unknowns, R and H, unknowns of our water level. So we try to have only one unknown, which is given out the problem, we try to find H. So let's try to get out R in terms of H. We look at the shape and try to imagine our water level. We know that we have a height which is 6, but let's hold that height for now and our unknown radius. Then we just use the principle of ratio of proportion. We get 5 over 10 equals to the unknown radius 8. And then we get that R equals to 1/2 8. Then let's plug that in. D is equal to 1/3 by 8 over 2 squared 8. Simplify 1/3 by 8 cubed 4. Then we know that this is dv of dt, so let's try to make this equation as a differential equation. Let us derive this in terms of time d over dt. Then dv over dt is equal to the derivative is bring down 3 cancel, then 1/4 by 8 squared dv over dt. Then let's simplify again because what we're trying to find is dh over dt, the water level. So let's make this on one side, dh over dt is equals to 4 over 5. Let's plug in 6 squared dv dt. Now then plug in dv dt which is 9. Solving 4 times 9 over 5 6 squared. We get our water level changing 0.32 feet per second. Minute.